Hi everybody, welcome to Chapter 12a, where we are going to be learning about sequences. So first, let's talk about what a sequence is. That definition is a function whose domain is a list of consecutive integers. So here's an example. We've got 3, 7, 11, 15, 19. To kind of show you how we denote things, this a1 equals 3, that means our first term is 3. Here, for example, if that's a4, that means that's our fourth term, which is 15. Another term we're going to learn about in a little bit. So let's look at what's happening between our numbers each time. So how are we getting from 3 to 7? How are we getting from 7 to 11? Well, what's happening is we're adding 4 each time. So that's called our common difference, and we'll talk about that more on the next page. But that's just the what's happening each time. Okay, so going to the next page, we have some vocab. An arithmetic sequence is a sequence where the consecutive terms have a common difference. And common difference, we just talked about that. That's like the what's happening each time between our terms. But the formal definition is the constant value you set when you subtract consecutive terms in an arithmetic sequence. All right, so let's look here just identifying an arithmetic sequence. So it says, tell whether the sequence -5, -3, -1, 1, 3 is arithmetic. So to be arithmetic, it has to be adding or subtracting by the same number each time. So let's take a look. To get from -5 to -3, we had to add 2. -3 to -1, we had to add 2. Add 2 and add 2. So because we're adding 2 each time, the sequence is arithmetic. And our common difference is 2. All right, so let's go on to the next page. The rule for an arithmetic sequence, sorry, I keep coughing here. The rule for an arithmetic sequence, we've got a sub n, is how you say that, is equal to a sub 0 plus dn. So the a sub 0, that means our 0 term. And you won't see our 0 term in the sequence. We have to find that out on our own because it always starts with the first. And then the common difference, the what's happening each time. So let's look at this example. It says write a rule for the nth term of the sequence, then find, so that a19, that means the 19th term. So to write a rule, that's a sub n is equal to a sub 0 plus dn. We have to plug in a 0 term and the d. So I'm going to just put a spot over here to label. And I like to have a sub 0, yeah, we plug that in. D, we plug that in here. We don't really have the first term, but I like making sure that we know the difference between the 0 term and the first term. So the first term I can see right away. Some colors here. The first term, that's 2. Okay. And our common difference, I can see each time it looks like we're adding 7. So our common difference is 7. But what about our 0 term? So the 0 term is like, well, what happened before? So if we were to go backwards, like subtract 7, right? So if we were to do that, that would be -5. And -5 plus 7 is 2. So that still works in our sequence. So -5 is our 0 term. So now we can plug in everything we know. So a sub 0 is -5 plus d is 7, our common difference, n. So this right here, that's our rule. We finished that step. That's great, okay? But it also asks up here to find the 19th term. So this is our first term, second term, third term, fourth term. You could keep adding 7 all the way up until the 19th term. Or you can say a sub 19 and plug in 19 for n. So that becomes -5 plus 7 times 19. And that's a great problem for your calculator, right? All right, so 128 would be our 19th term. All right, let's look at the next example. So we need to write a rule again. So remember, our rule is a sub n is equal to the 0 term plus the common difference times n. So I like to label, well, what is the 0 term? What's our first term? And what is our common difference? So our first term is 57. And let's see here, what is our common difference? So this time it's going down, but that's okay because it looks like it's subtracting 12 each time. Okay, so that's 12. But now, let's think here. Let me get rid of this B. So let's think here. What would have come before 57? So we just have to go backwards, right? So if I took 57 plus 12, this term here would have been 69. So that's our a sub 0. So now we're going to plug in our a sub 0 and the common difference. So a sub n is equal to 69 plus 12, negative 12, my fault. That should be negative because we're going down each time, sorry. And then it wants the 19th term. So a sub 19 is equal to 69 minus 12 times 19. Again, great question for your calculator. And that's negative 159. Okay, and that is the end of our notes on arithmetic sequences. If you'd like to try this checkpoint and then check in your notes, I think that'd be great. Otherwise, the next video will be about geometric sequences. Thank you.